This lecture deals with basic mathematical operations used in this statistics course. Key topics include powers, roots and radicals, negative numbers, order of operations, and summation. So you may have heard that statistics involves mathematics, and it definitely does, but knowing certain basic mathematical operations and the meaning of certain symbols is enough to be able to succeed in this course. And so we'll begin with powers, roots, and radicals. What are these things? Well, raising a number to some power means multiplying that number as a factor as many times as the power indicates. So any number raised to the first power is equal to itself. And so as an example of that, if we take x, which represents some variable, and we raise it to the first power, we get x. As a more concrete example, if we take some number like 3 and raise it to the third power, it equals 3. And so basically any number raised to the first power, again, equals itself. The particular power indicated by that small numeral is called an exponent. And so, for example, using the number 2 as an exponent is referred to as squaring. And that indicates to multiply a number as a factor 2 times. And so as an example of that, x raised to the second power, or x squared, is just equal to x times x. And so 3 squared would just be equal to 3 times 3, which is equal to 9. Using a 3 as an exponent is called cubing, and that indicates multiplying the base number as a factor 3 times. So as an example of that, x cubed is going to be equal to x times x times x. 3 to the third is going to be equal to 3 times 3 times 3, or 27. And then note that any number raised to the 0 power equals 1. So x to the 0 power equals 1, 3 raised to the 0 power equals 1, etc. Now the opposite operation of taking some number and multiplying it to a power is to take the root of the number. And so taking the root is basically the opposite operation of exponentiation. So a particular root is indicated by a radical sign. And together with a small number outside the radical sign called the index, or radicand, that indicates which root is being taken. And so, for example, we could take the square root. And this is when the radical sign doesn't include a number. So if there's no index number, it's understood to be 2. And as an example, because x squared equals x times x, if we take the square root of x squared, which is shown below, the resulting value will just be x, or the opposite operation of squaring. Note also, however, that negative x times negative x also equals x squared. So if we take the square root of x squared, really the answer could be both negative and positive x. And so typically we ignore the negative square root. Most often we use the positive square root, although both are acceptable. And so as a more concrete example, let's say you took the square root of 9. Well, because 3 times 3, or 3 squared, is equal to 9, the square root of 9 is going to be 3. And again, note that negative 3 times negative 3 is also 9, so an acceptable answer is negative 3. But again, in practice, we often ignore the negative root in favor of the positive root. If the number 3 is outside of the radical sign, that indicates taking the cube root, and that's basically the opposite operation of exponentiating, or cubing. So x times x times x is equal to x cubed, and so if we take the cube root of x cubed, we're just left with x. Since 3 times 3 times 3 is equal to 27, if we take the cube root of 27, it's going to be equal to 3. Okay, now that we understand something about roots, powers, and radicals, let's talk about working with negative numbers. And so there are some important rules when working with negative numbers. So the first is that when you add a negative number, it's like subtracting it. And so if we had two positive values, x and y, and we added negative y to x, that would be like subtracting y from x. As a more concrete example, suppose we wanted to add 5 to negative 2. Well, 5 plus negative 2 is like 5 minus 2, which is just 3. A second rule is that when we're subtracting negative numbers, it's like adding their absolute value. And so, again, if we have two positive values, x and y, if we subtract the negative of x, it's like adding, the negative of y, it's like adding y. And so x minus negative y is like x plus y. As a more concrete example, if we were to subtract negative 2 from 5, it's like adding 2 to 5. And so 5 minus negative 2 is like 5 plus 2, which equals 7. And then a third rule is that when we're multiplying or dividing a negative number and a positive number, the result is going to be negative. And so if we take, again, two positive values, x and y, and we multiply positive x times negative y, the resulting product is negative xy. And so 5 times negative 2 is going to give us negative 10. And then when we divide two negative numbers, or we multiply two negative numbers, the result is going to be positive. And so again, if we have two positive values, x and y, if we make them both negative, and we multiplied negative x times negative y, we'd get xy. Likewise, negative 5 times negative 2 equals positive 10. And then when we're squaring negative numbers, the result is always going to be positive, because it's basically like multiplying two negative numbers together. So negative x squared is like negative x times negative x, which is just positive x squared. And then negative 5 squared is like negative 5 times negative 5, which is just positive 25. Now let's talk about order of operations. So statistics can involve solving lengthy equations that require several steps. But if we follow two basic rules, we can solve even the most complex equations. And so the first is something called rules of precedence. And this tells us to solve from left to right in this following order. First, we start with exponents and roots. And then we proceed with multiplication and division. And then third, addition and subtraction. The second rule has to do with parentheses. Anytime you see parentheses, solve the expressions within the parentheses first. And solve expressions within parentheses, then within brackets. And so the rules of brackets and parentheses override the rules of precedence. So let's look at some examples. So here we have 4 plus 6 times 8. So how should we solve this problem? Well, rules of precedence tell us to start from left to right and start with exponents and roots, which there are none of here, and then move on to multiplication and division. And so we can see that we have 6 times 8, and so that's going to be 48. And then move on to addition and subtraction. And so first we're going to multiply the 6 and 8 to get 48, and then we're going to add the 48 plus 4. That gives us 52. How about this example? Well, again, we use rules of precedence, and we have to start with squares or roots or radicals first. And we see we have 3 squared, which just gives us 9. And now we'll use the rules of precedence and go from left to right and do any multiplication, division, and so on before doing addition and subtraction. And so first we multiply 4 by 6 to give us 24. Next we're going to divide 24 by 9 to give us about 2.67. And then we subtract that from 6, which gives us 3.33. How about this example? Well, we see here that we have some parentheses. And so recall that the rules tell us to start with parentheses before doing rules of precedence. And so we have 4 plus 3, which is 7, 3 minus 1, which is 2. And now we're just going to use rules of precedence. And we're going to start with the 2 squared, which is 4. And then we're going to multiply 6 and 2, which is 12. We're going to divide 12 by 4, which is 3, and then subtract 3 from 7, which gives us 4. Let's talk about summation now. So summation basically involves finding the sum of some array of numbers. And so an uppercase Greek letter sigma is often used to designate the summation operation. And it basically tells us to add together or sum a group of numbers. And so for example, you might see something like the following. You might see a summation symbol where there's an I indexing individual values of some variable. And I will be summed from I equals 1 to n. So n is at the top of the summation symbol, I is at the bottom. That just basically tells us to take values of some variable, in this case x, which is indexed with I. So I here refers to individual values of some variable x, and add them from the first value of I to the nth value of I. So n basically refers to the number of cases that we're dealing with. And so if we saw something like this, the sum of x sub I from I equals 1 to n, that just tells us to take each value of x, x1, x2, x3, all the way to xn, and add them all together. And so as a concrete example, let's suppose that x here represents some variable like age. And let's suppose that we have the ages of 4 college students who are age 19, 21, 23, and 32. Well, the summation operation would tell us to just add the 4 ages together. And so here n would equal 4. And so we're going to take the sum from the first to the 4th case. And so we're going to add 19, 21, 23, and 32. And we're going to get a value of 95. Note that we sometimes use a shorthand for summation. Rather than using the I equals 1 at the bottom and n at the top, sometimes we leave those out, and we just write it as sigma sub x, sigma x. Okay, it's also the case that summation works with order of operations. And so look at the expression below, the sum from I equals 1 to n of x sub I minus c. What's the proper order of operations for that expression? Well, what we do is we take each value of x from I to n, and in each case we're going to subtract c. So for x1 we'll subtract c. C is some constant. x2 we subtract c. x3 we subtract c. All the way to xn subtract c. And so as a concrete example, suppose again that we use the 4 ages for those 4 college students between the ages of 19, 21, 23, and 32. And let's suppose c, our constant, was equal to 2. So how would we solve that expression? Well, we would take 19 subtract 2, which gives us 17. 21 subtract 2, which gives us 19. 23 and subtract 2, which gives us 21. And then 32 minus 2, which gives us 30. And then we're just going to add those together. So 17 plus 19 plus 21 plus 30 gives us 87. Now look at the 2 expressions below. What's the difference between the 2? Well, you can see that the first expression tells us to take the sum from I equals 1 to n of some variable x sub I minus c squared. And so basically there, what we're going to do is we're going to take the difference between each value of x and c, the constant, and square it, and then add them together. Whereas the expression at the bottom tells us to take the sum of x sub I from I equals 1 to n and subtract c, and then square the resulting quantity. And so there we would take x1 minus c, x2 minus c, x3 minus c, all the way to xn minus c, and we're going to square the entire expression. And so there's a little bit of a difference. And so for the first one, we're going to square each one of them. So x1 minus c squared, x2 minus c squared, x3 minus c squared, all the way to xn minus c squared. And for the second expression at the bottom, we're going to take x1 minus c, x2 minus c, x3 minus c, xn minus c, and only then do we square it after we sum them.